project this semester is a bulk food store project, and what you should see is this coming up when you have everything done. And all of the information that you see on this screen should be produced in a function called menu, and menu should be able to display all this stuff, and it should have passed into it from the mainline program all of these values for pounds. So initially the number of pounds you're going to put in is 0. It should then, inside the menu portion with all these values passed in, multiply the number of pounds here times A, the number of pounds for B times the cost per pound for B, and so on, to generate subtotals. So 0 times 4.55 is this, and so on. And then add all these together to get the subtotal, add PST and GST amounts, and total these up to get a final total. It should also take all of the pounds that are here, add them together, and get the total number of pounds. And it should also calculate the average cost per pound. Now when you first start up, the average cost per pound is going to be a problem because it should print 0 for the average cost per pound if the number of pounds is 0, because you cannot divide by 0. It will crash your program. Now it should be able to take either uppercase A, and here's the way the menu function is going to work. It's going to take in all of these values per pound, and it's going to pass back to menu a character, whatever character you select. When it goes back to the main program, it's going to then, from the main program, ask you to input the number of pounds in a range of 0 to 100. So if I put in, say, -2, it shouldn't do anything. Also, if I hit in a letter, watch here carefully. If I punch in a Z, it should say error. If I punch in something that's not right, like a 5, which is not proper input because it should only accept A through H, R, and Q, uppercase or lowercase. Those are the only things that it should accept from this menu. Now, if I type in A and I type in 3.3, or any value, 3.32, notice what it's done. 3.32 times 4.55 generates this number, and it multiplies all these, whether they have zeros or not, adds all these up to get a total. Notice the average cost per pound as you're checking your code should be for whatever. If you have a single item, doesn't matter how many pounds you've got here, the cost per pound should be the same value as cost per pound here. So if I want to change A, I can type A again. I can type in 33 or say 23 or something like that. And again, you'll notice the cost per pound is still 4.55, but now 23 times 4.55 is this number, and it's going to calculate a different total. Now at any point, you should be able to hit R for reset and put all these values back to normal. And so you should be going to say A1, B2, C3, and so on. Be able to fill these up. D4, E5, F6, and G7, and H8, something like that. And as this is a test, you should see if you put 1, 2, 3, 4, 5, 6, 7, 8 here, the numbers you should get here for the subtotal is $50.98. The total should be $57.61, assuming a GST of 5% and a PST of 8%. If you don't get that, then there's a problem. Now, one of the things your program should do is take this from defined statements. So if I change the defined statements, it should change the description. You should also get the cost per pound also from defined statements from within your program. And by changing either this or this, it should change what goes on. Now, I'll be demonstrating how to do that and how to do this fancy print formatting and so on later. But we also have some other issues to deal with as well, as we'll see. But for now, I'm going to hit R for reset. It should put everything back. And if I hit Q for quit, it should say press any key to continue. And then if you do hit any key, it should drop you back out, as you've seen here. Well, let's consider this small program that we've got here. Okay, let's take a look at this small program that we've got here. Up here, you're going to put your programmer's block, your normal includes, and I've got a couple of defines here to indicate some stuff that you may not be aware of with some of the fancier print formatting. We've got basically the structure. We're going to have programmer's block, include section, define section, function prototypes, your main line, and function definitions down here. That's going to be your basic setup to get started. Now what I was going to do is show you a little bit about printfs that you may not be aware of. So let's take a look here. Notice we got double quotes here, another set of double quotes here, double quotes here, another set of double quotes here and here. And you're asking yourself, well, is this going to work? And the answer is yes. This is just printing a string, another string, and another string, all inside the same printf. Now, I think you'll notice here, this is quotes here, quotes here. Notice we've got a variable over here, and if I mouse over it, it says number sign defined Dave 4.56. So whatever Dave is, which is a 4.56, is in here. This is called a global constant because you're defining Dave as this, and anything that's defined up here can be global constants or global variables. Never, ever put in this area outside of a function, never define a variable of integer, char, or float, because that's a global variable. You're going to be heavily penalized. It's a very, very bad programming practice. But in terms of defined statements, that's fine to put these globals up in here. And so if you notice here, let's see what happens when I run this, and we'll get an idea. Let me just slide this down here. But notice what's going on. It says, well, a couple spaces, and then it gives a print format specifier \t. Well, notice that it's taken the Dave, which is 4.56, and substituted into this string here, even though it's not the last string. Any of the strings that you put any kind of print format specifier in, we'll take whatever variables. They might put 1 or 2 here, could put print format specifier here, and as long as you got enough variables, it will print them in here. And that's a concept that you have when you go back, if we think about it, how that original program looked and how to put stuff across the screen. Now let's take a look at another example. Now notice it says, hi, how are you? Hi there, how are you? And it says the same thing here. Hi there, how are you? Now if we take out this entire string, let's do that. Take it out and replace this with the word Bob. Now Bob itself is going to be, as you can see here, if you can focus in a little closer, I don't know whether I can bring this up. No, I can't. But in this case, what you're going to see is that it's going to put into here, well, a couple of spaces, and Dave, which is 4.56 as it did before. But then notice this Bob is just another string, and it's going to substitute this entire string because Bob, as a define, is going to be equivalent to all of these, the same exact string as we had in here before. Well, let me run it up and show you and see that indeed it hasn't changed anything except that what it's done is that Bob now, hi, how are you, is put into here as part of a number of strings. Now this is how you're going to set up the number sign defined statement so that you can change those very easily to have different output come up. So for instance, if you take a look at the way the project's set up, if I change Bob to say hi are you, I can have it say something like, I don't know, cream corn or something, which could be one of the things that you've got on your project as one of the things, and Dave could be a price. Now if I do that and I run it up again, what we're going to find is that notice now, instead of saying, let's see if I can drop this down a little bit and get rid of this and bring up my output screen again, you'll notice here that Bob now is creamed corn. So whatever I put in for Bob is going to substitute whatever Bob is into this anytime I run it. So this is the thing that we're talking about before. By changing the defines of all the stuff that's given in your project, you should be able to change the name at any point just by changing the define and change the price or the value that's in here, and it should be able to use that in a calculation. The other problems that you're going to run into is dealing with input, and scanf is not always the best option to use when you're dealing with input. So when you use scanf, you can have issues. And let's take a look, because one of the things you may have seen in the video, and it was a little hard to see, is that when I want to grab input from the keyboard, I don't necessarily want to hit, for character especially, I don't want to have to hit an enter key. So if I hit A, I always have to hit an enter key, and then it will output what we've got here. Now I'm going to suggest another way of doing this. And instead of doing the scanf, you should always flush before you scan. But I'm just going to get rid of that, and I'm going to do something that's kind of different. I'm going to say Bob equals get ch. Now, as you saw before, there's a difference between get char and get ch. Get ch waits and grabs a character from the buffer, and we've used it in the past down here, as you can see, to actually terminate or to hold the screen open to see stuff. But in this case, we're going to use it to actually grab a character from the keyboard and put it into a variable Bob. And the way we do this, as you may have seen here, is we're just going to say Bob equals get ch. Let's try that and run this up and see if it works. And sure enough, when we get to this point here, if I hit an A, it prints an A on the screen. It's actually, if I bring this down here and take a look at that output screen again, it's actually taken the character from the keyboard here, and here it's echoed it back after tabbing it over. Now notice the one thing it didn't do is it didn't echo it as I typed it. So let's see how we can get around that problem, because there's going to be times we want to do this. I'm going to get rid of this printf, and I'm going to put ch. Get ch is how you get a character from the keyboard. I'm going to put ch Bob and actually echo it back on the screen. So let's run this up and see what happens. I'm just going to hit runner up here, so let's hit the little run button. And in this case, if I slide this over here, if I hit the A, notice it didn't tab over anything because this grabs it from the keyboard without sending anything to the screen, and then put ch actually echoes the character Bob back up to the screen. So this is a good way to put characters on the screen without having to hit the enter key. So that's one way we're going to deal with characters. Another problem that we're going to have is when we start dealing with floats and other data types, but floats particularly because we're going to be using floats in this project. So scanning F is not always the best way to deal with things. Let me show you why. Let me just run this portion of code up and get an idea of what's going on. Now if I put in something like 33.33 and hit enter, notice what I'm going to get here is it's going to have round off error. It's going to not be exactly 33.33. It's going to have other digits and so on coming up in the output. So there are issues just with grabbing it. Not only grabbing it like this, but for instance, if I was to run it one more time, and this is the hard part to check in your program, if I type ABC when it's expecting a float, what's going to happen then? Well, let me just punch up and you can see that it's going to come up with some weird number. And that weird number is not exactly what we were planning on, and it could cause major problems for any programs that we write. So what I'm going to suggest is a new way of dealing with things, and this is something similar to what we've seen in a prior lab that we did. I'm going to say char name. It doesn't matter what I call it, but this is the same as we used in one of our previous labs. I'm just going to set up a character array of name, and instead of doing a scanf, I'm going to do something that we did before. I'm going to say get string, and I'm going to say name, which is what we've used before to get a string of characters from the keyboard. And the concept is here that once we get it as a string, we're going to then say Bob is going to get name. We're going to get ATOF of name. Now ATOF, let's take a look at this a little closer. And the concept is here we're going to replace the scanf with a get string of name, make sure we've got char name of 80 or whatever. And the reason 80 is because there's 80 characters across in the screen if we want to type in something huge. But notice here we're going to say get string name, so we're going to get all the characters from the keyboard as a string. And then the ATOF function is kind of interesting. It says ASCII to float. And it's going to take whatever characters that you have in what you've typed in from the keyboard and try its best to return the appropriate thing. So let's take a look and see what's going to happen when I run this version up and see how it's going to be a little bit different. So I'm going to type in the same stuff again. I'm going to type in something like ABC and hit enter, and notice it's going to come up with 0. So the ATOF function is going to make sure that if I type something that starts with a character, it's going to return a 0, which makes things a lot easier for us to deal with and will mean that our program will not do unacceptable things. Now also, if I do something like 33 ABC, it's going to return 33. So this is one way of cleaning up and dealing with input from the keyboard. And again, let's take one last look at this, is to actually, whoops, let me get rid of that, is to actually change it from a scanf that we had before to a get string name, and then the original float that we used, we just use that to assign to ATOF of name, and that gets around a lot of problems we're going to have with floating point input from the keyboard.